welcome you back to this lecture series of multivariate calculus. So in this lecture I will talk about the Jacobian of the same multivariate calculus for the third three variables. Okay, so here you have three variables, let's say u, v and w, and these u, v and w are basically function of x, y, z. Then the Jacobian of these things, u, v, w and the x, y, z will be denoted by this term del of x u, v, w by del of x, y, z, or the j of u, v, w by x, y, z, and I can evaluate this term that is equal to this determinant. So this is the 3 by 3 determinant, and first one is del u del x, del u del y, and del u del z. And similarly, second row will be del v del x, del v del y, and del v del z. And the last row will be del w del x, del w del y, and the last term will be del w del z. Okay, so this is basically the Jacobian for three variables. So you have u, v and w, three variables. Suppose u is a function, let's say a function of x, y, z, sorry, and v is also a function of some other function, let's say g of x, y, z, same variable. Now, and w is a function, let's say h. So w is a function that is h of some x, y, z. Okay, and by using this determinant I can find out what is the Jacobian of this variable. Now let us solve one example to find out what will be Jacobian for this corresponding variable. So you have three variable x, y, z, and that is related to r, theta, phi by this equation. So here x, y, z are basically function of r, theta and phi, and y is also function of r, theta, phi, and z also similarly. Now here basically if I want to find out the Jacobian, that is del of x, y, z, del of r, theta, phi, we have to show that is r square sine theta. So I'll start with the determinant. So we know that this term equal to this determinant value. So del x del r, del x del theta, and del x del phi. And second row is del y del r, del y del theta, del y del phi, and del z del r, del z del theta, del z del phi, exactly. Now I know x, that is equals to r sine theta cos phi. So by partial derivative, this term will get r will be removed, so it will be sine theta cos phi, right? And next term will be r sine theta cos phi, and the last one will be negative of r sine theta sine phi, right? Similarly, for this one, if I derivative this term with respect to r, then first r will be removed, so r theta sine theta, so only sine theta sine phi, this one, and next term I'll partial derivative this thing with respect to theta, so it will be r cos theta, right? R cos theta sine phi, and again if I differentiate this one with respect to phi, so it will be cos phi r sine theta cos phi. And last one, here we have r and theta, phi is not there, so partial derivative with respect to phi will be 0, right? And for this with respect to r, it will be only cos theta, and with respect to theta it will be negative of r sine theta. Now we have to evaluate this determinant. So this is basically 3 by 3 determinant, and I have to take some intuition or take some common if in this variables, if they have any, then we can easily solve this determinant. We have can easily break this determinant. Let's find out. So I think in the last column, if you see, there is one term r sine theta is common here, right? So I can take the r sine theta common from the third column. Then I will take this common, then ultimately it will be okay. I can get r common. Let's see in the last yes, in the second column I can get r common. In the third column I can get r sine theta. So basically r square sine theta I am taking common of this determinant. Then the remaining part will be this one. Now if I break this determinant or evaluate this determinant, expand this determinant from this third row or the third column, then it will be easier. So basically here we are expanding this determinant from in the respect to the third row. Okay, so first this term, so r square sine theta is already there. So then it will be cos theta and determinant of this term. So that is equal to cos theta sine cos phi, negative of sine theta sine phi, and cos theta sine phi and cos phi. And next term it will be positive, right? Negative, so negative positive plus of sine theta. Then this term, this one, and this one, and this term, right? With respect to this one. Okay. So it is sine theta cos phi, negative of sine phi, and sine theta sine phi, and cos phi. Then I have to break this, expand this 2 by 2 determinant. I can easily break this one. So let's expand this one. So I already know this term already there. So now they have cos theta cos square phi and plus of sine theta cos phi, right? Sine theta cos theta, sorry, cos theta sine square phi, cos square sine square phi, and the last this term sine theta is already there. Sine theta is there. Now here it will be sine of cos square phi plus sine theta sine square phi. Okay. Now here if I take the common cos theta, right, then it will be cos square phi plus sine square phi, that will be equal to 1. And here if I take sine theta common, it will be sine square phi, sine square theta, and cos square phi cos square theta, that is 1. Okay, thank you. See you in the next lecture.